Good morning, all of you. Today we will learn stellar energy, proton-proton cycle, carbon-nitrogen cycle, and difference between nuclear fission and nuclear fusion. So let's start proton-proton cycle. Or first, what is the stellar energy? The stellar energy is nothing but what? Internal energy of star. Okay. What is stellar energy? Internal energy of any star. That is what stellar energy is. Now proton-proton cycle. See, what is this? This is proton plus one more proton when we are adding. It gives deuteron plus one positron plus neutrino plus energy, that is how much? 0.42 mega electron volt. Now this positron, call this equation number 1. This positron, if we will add with an electron, then it gives two gamma particles plus 1.02 mega electron volt energy. This is your second equation. Next, now again this product, that is deuteron, when I am adding with one more proton, then it gives helium isotope plus gamma particles plus 5.49 mega electron volt energy. Next one, again this helium isotope plus one more helium isotope gives helium plus two protons plus 12.86 mega electron volt energy. Call this equation number 4. Okay. Now 2 into equation number 1 plus 2 into equation number 2 plus 2 into equation number 3 plus this 4, net effect is 4 proton plus 2 electrons, and this is helium plus 2 neutrino plus 2 gamma plus 26.7 mega electron volt energy, and 4 proton plus 4 electron gives helium plus 2 electron plus 2 neutrino plus 6 gamma plus 26.7 mega electron volt energy. This is what proton-proton cycle. You just note down, they are not asking most of the times this in exam, just you should know it. Okay. Right. So note down this. Next one is carbon nitrogen cycle. carbon nitrogen cycle. So here carbon 12 6 plus 1 proton or hydrogen will give you nitrogen isotope plus gamma particle. Next, now this nitrogen plus or just nitrogen only, this gives carbon isotope plus 1 positron plus 1 neutrino. Again this carbon, when I am adding with 1 proton, it gives nitrogen plus gamma particle. Again this nitrogen I am adding with proton, it gives oxygen isotope plus gamma particle plus this neutrino, anti-neutrino this is. And now again this oxygen, it gives nitrogen plus electron plus this neutrino, and this is again nitrogen plus 1 proton, gives you carbon plus helium. Okay, like that this is carbon and nitrogen cycle. See, carbon to nitrogen you got, now here nitrogen to carbon. Clear? Yes. So note down this, and if we will see net result of this reaction, 4 proton gives you plus 2 positron plus 3 gamma particles plus 2 neutrino. You can see here. Okay, so note down this. Okay, next, last one, that is difference between nuclear fission and nuclear fusion. Difference between nuclear fission and nuclear fusion. So here I am writing fission, and here I will write fusion. We will make one column. This is just for your understanding. Let's make one column, or we can say difference table. Okay, so what is this fission process? You know, heavy nucleus, first point, heavy nucleus split into two nuclei. Yes or no? Heavy nucleus split into two nuclei. Next point, or here in this first point we will take, now here what happens? Unstable lighter nuclei combined, because fusion is what? Combined combination of two lighter nuclei. Yes or not? So unstable lighter nuclei combined to form a stable nucleus. Unstable nucleus. Next point, in this fission, neutrons are required. Neutrons are required. Neutrons are required. Yes. In this, protons are required. What is required for fusion process? Protons. Okay. Next point, possible at normal temperature and pressure. This reaction, that is fusion process or fission process, possible at n means normal temperature and pressure. Right? In this, possible at high pressure and temperature. Possible at high pressure and temperature also. Possible at high pressure and temperature. Okay. Which one? This fusion process. Next one in this, fourth point, energy released per nucleon. is nearly equal to 0.9 mega electron volt. Okay, energy released per nucleon is how much? Nearly equal to 0.9 mega electron volt. In this, energy released per nucleon is nearly equal to 6 mega electron volt. How much? 6 mega electron volt. Got it? So here it is nearly equal to. Here also nearly equal to 0.9 mega electron volt. Okay. Next one. Fifth point. Percentage mass getting converted into energy is equal to 0.1%. Okay. Here percentage mass getting converted into energy is equal to 0.7%. How much? 0.7%. Right. Next point. Fissionable materials are expensive. Fissionable materials are expensive. Here fissionable materials are, now here it is fusionable, है ना? Fusion materials are cheap, not expensive. Fusionable materials are cheap. Okay. Right. Next one. Last point. Harmful radiations are produced in the fission process, whereas in this case harmful radiations are not produced. Not produced. Okay. Right. So this is what the difference between fission and fusion. note down this all. Okay, yes, note down this. Okay, so this is what the nuclei chapter. Here it will end. We'll start new chapter on Monday. Okay, so let's stop here for today. Bye.